geochemist Christian Kerbel from Vienna is now totally convinced that a meteorite was involved in forming the mysterious glass found in a remote part of the Sahara Desert. For him, the lack of a crater doesn't create a problem. He has an easy answer. The crater has simply disappeared with time.
I think what we're looking at is probably a very deeply eroded structure. A fresh young crater looks maybe like this, and it is filled in here with broken bits of rock and melt and so on. But with time, all this disappears, and all that we might have left is this central area here, which is very difficult to detect.
But a meteorite large enough to scorch and melt such a vast area of ground had to be big. And even if the crater's been eroded, there is one way it ought to be possible to spot it: by looking from space. Farouk Al-Baz is a remote sensing man. He's head of the lab in Boston that interprets pictures of Earth taken by orbiting satellites. He's been looking at pictures from space since the 1960s. Back then, only about 20 impact craters had been found.
With the advent of satellite images from space and the fact that we're going to be recognizing all of these circular features, we now have at least 200 that are proven or semi-proven impact craters.
One reason there are not more known impact craters on Earth is that some are so big they can only be spotted from space. And the older they are, the harder they are to find.
It is really important to look for a crater that has the right age for the formation of this glass, because if we say that this glass is of meteorite origin, which is most likely, then there should be a crater of that age that would have formed that glass. So these things must come together.
To help Al-Baz in his search, he needs to know when the glass was formed. Was it yesterday? Was it 1,000,000 years ago? Or 100 million? One technique for dating is based on the rate an isotope of the mineral uranium decays. It leaves tiny scratch marks on the glass, which when counted, gives the age. This method produced a date for the desert glass. It was formed nearly 30 million years ago. But is it possible to find a 30-million-year-old crater?
It's not really a problem in this part of the world to locate a 20 to 30 million year old structure, because no matter what the erosive processes were like, you still have in the subsurface the imprint of that impact. For instance, we have the structure here in Chad that has been dated to be older than 200 million years, which means that anything that is 20 or 30 million years would certainly be visible.
So Al-Baz and his team have been searching the area looking for suitable candidates.
We have some craters in here, a tiny one in here, larger craters in south of here, but nothing in that zone that can be called an impact crater. So here is the Great Sand Sea and the dunes going down southward this way. And the silica glass region is right here, and it is a little too far from any of the impact craters that we have formed around. So we conclude from that we have not really found the smoking gun for the silica glass in the Western Desert in Egypt.
While studying the satellite images during filming, Al-Baz spotted a circular formation that he thinks needs closer inspection. But the formation is 100 kilometers from the main concentration of glass, and other scientists remain doubtful that this could be the source. Yet if there's no crater, then some enormously powerful cosmic event happened here nearly 30 million years ago and left little more than glass behind. It's this seemingly impossible puzzle which could be solved by the new theory Mark Boslow is developing. The theory started with a catastrophic event, not in the desert, but in a place called Tunguska, in the forests of Siberia. In 1927, a Russian scientific expedition visited Tunguska to investigate a massive explosion. The explosion had actually occurred in 1908, but Tunguska is so remote, it was nearly 20 years before they were able to see what had happened. They were astounded at the scale of the devastation. The blast had destroyed more than 80 million trees. The scientists were puzzled. What could have caused such an enormous explosion? Their first thought was that it was a meteorite, but they couldn't find a crater. They searched for fragments of a meteorite and found nothing. They returned to their laboratory and carried out a series of experiments. The destruction of so many trees mystified them. No one had seen anything like this before. The Tunguska event became a scientific mystery. Since then, scientists have had many theories, but it's now assumed that an extraterrestrial object somehow exploded about 8 kilometers up in the atmosphere. This mid-air explosion, they call it an aerial burst, would have been equivalent to about 20 million tons of TNT. Over 1,000 times bigger than the atomic bomb at Hiroshima. Maybe a similar aerial burst, but far bigger than this one, melted the ground in Egypt and turned it to glass. But could such an aerial burst reach temperatures hot enough to melt the ground? The world's first atomic bomb blast would provide the answer.